All right, so welcome to Lab 1 Group Four's pitch on this year's Math Visualizer. I'm Nihal Singh and I'll be giving you guys a general introduction of what we've been working for the Math Visualizer. So, just a general introduction. Over the past few weeks, ever since like the start of the semester, we've been working on a sort of a visualizer, sort of a prototype, or sort of a platform where students can understand math concepts and they can clarify their doubts. So, in hindsight, we've been working on the concept of derivatives, and this came about uh, when we interviewed a couple of high school teachers, and while interviewing them, we understood that the main thing that students were struggling on and what they found really hard to adapt on was the concept of derivatives. So we took that into an idea. We took that as a sort of a motivation. So using the Elm IDE, over the last few weeks, we started constructing bits and pieces of a sort of a visualizer that not only sticks to just one sort of style of learning, but it helps integrate visual and like theoretical learners as well. So this visualizer that you will see, it basically helps suit for all styles of learning essentially, and it's sort of a platform where you can test your skills as well as learn along the go. So it's a really great sort of prototype which helps students just enhance their learning. Now, obviously, the user for this particular prototype will be high school students, but it's not only constricted to that, right? It's constricted to any and all actually, and it's open to anyone who's just struggling in the concept of derivatives or just having trouble visualizing graphs and how uh, you can represent functions visually.
After interviewing a couple of high schoolers who struggled with derivatives, we were able to narrow down a few points to define the problem we were attempting to solve. First, we wanted to improve their understanding of the rules of derivatives, such as understanding the power rule, the quotient rule, how exponential derivatives work, and so on. Second, we wanted to help them learn when to implement these rules and properties in various scenarios. And finally, the most important thing we wanted to emphasize was having more practice, which would in turn help students be familiar with various types of questions. The starter idea of our visualizer was more of a rough concept of how we can implement different functions and generate random problems with solutions. We kept in mind that the emphasis should be on the clarity of the solution and that the purpose of the app is to develop a deep understanding of derivatives and how to solve them. The rough sketch of our visualizer allowed us to come up with more ideas and feedback from our peers and TAs, which helped us convert our idea into a functional prototype.
Now, we received a great amount of feedback on our initial idea in order to refine it further into creating a more detailed, perfected final idea of which to base our prototype after. One common piece of feedback that we got was that our user interface should be a bit more appealing. And so we scrapped the black and white palette. We added colors as well as a colorblind palette option with an option for dark mode as well. Uh, Another big piece of feedback that we got was that our app was too reminiscent of like a math quiz or quiz software instead of a visualizer or a game. So we scrapped the MyLab quiz style interface for which it was modeled after initially. We removed the question count and the more quiz-like format, and we also implemented a graph of the function at hand in order to help visualize the problem. Another piece of feedback that we got was that our user interface had too many buttons and that our hint function and our solutions function would be redundant. So we combined those into one function that aimed to assist the user into solving the problem while increasing the simplicity of the UI. So we had this more refined idea for our final project, and our goal was to still use derivatives to develop a deep understanding. It was to develop a deep understanding of derivatives in the students. Now we had auto-generated functions with auto-generated answers. We had a hint button to assist the user, and we had a counter to keep track of how many correct questions that the user made, along with our function graphed and displayed all prettily. So here's when we started to make our prototype.
So for the current prototype, it is a multiple choice game where the user has to pick out the derivative from the list of possible answers. The game currently has features such as hints and display answer. As you can see here, first of all, the function is listed up here and the function is graphed on the side. All the possible answers will be listed on the side, and the user can pick the correct one out of the three. For hints, a function is given and it goes step by step on explaining how the derivative is found and what to do for each step. On the bottom left hand corner, the derivative and the base function will be graphed. For display answer, the answer is displayed here and the user can easily now pick out the correct answer. Adding onto that, settings such as dark mode and red-green color blindness have been added for the user's comfort. As you can see here in the settings mode, I can toggle dark mode where all the black becomes white and all the white becomes black. In addition to this, colorblind mode has been added for those visually impaired with red-green color blindness. As you can see, all the red has become green, all the red has become pink, and all the green has become purple. The game currently has one type of question, but because of the random generator, it can generate roughly around 60,000 different questions, so therefore the user can have as much practice as they want.
So that's our working prototype as of now. We hope to implement additional features for our math visualizer over the next week or so. The first of these would be to add access values to our graphs, similar to graphing software such as Desmos and Wolfram Alpha. In addition to this, we would make our graphs and tables larger in the hints page and the derivatives page. An intermediate page would also be added so that users can know whether or not they got the question right or wrong, because currently it simply skips to the next question without providing any feedback to the user. Finally, we'd hope to implement another game mode where instead of tracking the number of questions done correctly or incorrectly, there would be a combo meter with lives to be added. If we had more time, we would want to implement even more features, including different derivative properties such as like chain rule and product rule. We would want to implement a zoom in feature for the graphs so that the user could see the graph in more detail and see specific points. We'd also want to implement things such as negative exponents and exponential functions and different types of questions that would allow for user input like text boxes.